Imagine holding a piece of granite, one of the hardest stones on Earth. Now, picture drilling a perfectly straight, smooth hole through it, using only simple hand tools. Yet, thousands of years ago, the ancient Egyptians did just that, with a precision that still baffles modern engineers. These holes are clean, elegant, and bear witness to a level of skill that feels almost out of time. This is not magic, but human ingenuity, an understanding of the natural world that let them carve their legacy into stone. Across Egypt, from Karnak to the pyramids, we find these telltale marks, perfectly circular holes, some narrow, some wide, with spiral grooves winding down like the threads of a screw. These grooves are the fossilized tracks of a tool, a ghost of a machine that bit its way through solid rock. How did a society with copper and wood tools conquer granite? The answer lies in a brilliant, counterintuitive method. They didn't overpower the stone. They patiently ground it away, harnessing the power of abrasion. But what was their secret weapon? Egypt's greatest resource wasn't just the Nile, but the stone of its deserts, granite, basalt, and diorite from quarries like Aswan. This stone was the embodiment of eternity, perfect for tombs and temples meant to last forever. The challenge shaping and hollowing massive blocks with only soft copper tools. Copper alone couldn't cut granite, it would bend or break. The solution came from the land itself, the desert's quartz-rich sand. On the Mohs scale, quartz is harder than copper and even granite. The Egyptians realized this gritty sand could be their cutting agent, the teeth of their saw, the blade of their drill. The tool became a device for applying pressure and motion. The sand did the real work. This principle of using abrasives is still used today, from tile cutting to lens polishing. The Egyptians pioneered this technique, turning desert sand into a powerful instrument of creation. The Egyptians' main tool for drilling small holes was the bow drill, an elegant, simple machine. It consisted of a wooden shaft, a bow with a cord, and a cap for applying pressure. The craftsman spun the shaft rapidly by moving the bow back and forth, generating surprising speed and torque. The drill bit was often a hollow copper tube, not a sharp metal point. The copper didn't cut the stone, it held the abrasive in place and delivered the spinning motion. The real work was done by the quartz sand, grinding away the granite. Operating the bow drill required skill and endurance, constant pressure, steady motion, and teamwork for larger holes. One person might operate the bow, another apply pressure from above. Drilling even a small hole could take hours of labour. But with this simple tool and the right abrasive, they could take on the hardest stone. The secret ingredient? The abrasive slurry. The Egyptians' true secret was the abrasive slurry, a gritty paste of quartz sand and water. As the copper drill spun, it trapped hard quartz crystals between its edge and the granite, grinding the stone into powder. The softness of copper was an advantage. Quartz grains embedded themselves in the bit, turning it into a grinding wheel. The process was slow and laborious, but incredibly effective. Modern analysis of ancient drill holes reveals traces of copper and abrasive and spiral grooves that mark the drill's progress. These grooves are not uniform, evidence of hand-powered work, with human variations in speed and pressure. The slurry had to be replenished constantly, and water cooled the bit and flushed away debris. It was messy, noisy, and demanding, but it let the Egyptians conquer the hardest materials. With copper, wood, sand and water, they unlocked the potential to build on an epic scale. For larger holes, the Egyptians used the core drill, a hollow copper tube that cut a circular channel, leaving a solid stone core. This method was vastly more efficient than grinding away the entire volume. Once the drill reached the desired depth, the core could be broken and removed, leaving a clean hole. Discarded stone cores found in ancient workshops are proof of this intelligent method. For big jobs, a weighted T-shaped handle replaced the bow, allowing multiple workers to rotate the drill. The abrasive slurry was poured into the cut as the copper tube ground its way downward. Some cores show the drill advance several millimeters per rotation, astonishing efficiency for the time. By drilling overlapping holes, they could hollow out massive sarcophagi and temple sockets with remarkable accuracy. The core drill was a perfect marriage of simple tools and brilliant concepts. The best evidence for these techniques is carved into the artifacts themselves. In places like the Serapeum of Saqqara and the granite temples at Giza, we see round, flat-bottomed holes and sharp interior corners, signatures of the core drill. Many holes are slightly tapered, wider at the top than the bottom. The spiral grooves inside are spaced wider at the top, tighter below. These features puzzled researchers, but they're explained by the manual process. As the copper tube wore down, it narrowed, creating the taper. Variations in groove spacing reflect changes in pressure and speed as workers tired. The flaws are the human signature of the craftsman, not evidence of lost super technology. Even the leftover cores show irregularities and wear patterns, realities of working with simple tools and tough materials. Each core is a record of hours of ancient labour. By studying these scars, we reconstruct the process and gain respect for the Egyptian skill and perseverance. Precision drilling was essential for Egypt's most sacred and enduring structures. Granite sarcophagi needed airtight lids to protect the pharaoh's journey to the afterlife. The core drill allowed for perfectly flat surfaces and tight-fitting joints. In temple construction, precise holes were drilled for joining pins and door pivots, ensuring flawless alignment. Mastery over hard stone was a political statement. Granite was rare, difficult, and a symbol of the pharaoh's power. Obelisks and colossal statues, shaped and drilled with this technology, projected authority and divine connection. Ultimately, this was about permanence. Granite was forever, and the Egyptians built their beliefs into the landscape. Their drilling was not just practical, it was ritual perfection, ensuring their creations would endure for millennia. The legacy of their precision is still visible in the monuments that stand today. The Egyptians' ability to drill granite wasn't magic or lost technology, it was brilliant problem-solving. They used copper tools not to cut, but to drive quartz sand, harder than the stone itself. The bow drill and core drill applied this principle, saving time and labour on their grandest projects. The evidence is etched in stone spiral grooves, tapered holes and discarded cores. These marks are the human signatures of ancient craftsmen. This mastery over stone was the foundation of their civilization's greatest achievements. Their methods still inspire us, reminding us that elegant solutions often come from simple ideas and patient effort. Their legacy, carved in granite, is a testament to human ingenuity and the power of turning a grain of sand into an empire. The story of Egyptian drilling connects us to our own inventive spirit. The same principles that guided ancient craftsmen are at work in modern engineering. We are part of a long chain of problem solvers, stretching back thousands of years. Their achievement challenges us to look at the world creatively and use the resources at hand. Monumental results come from many small, patient steps. Every artifact and tool mark is a piece of a grand puzzle, inviting us to be curious and to marvel at human creativity. The story continues with every new discovery, keeping history alive. Next, we'll explore an even greater mystery. How did they lift those colossal blocks to the top of the Great Pyramid?